I'm very happy to be with all of you here today. I'm Eti, and I'm part of the team that developed Azure Security Center for IoT. And our session today will focus on IoT security, but also we prepared a cool demo that will run a real attack on a device. Together with me, we have Idan and Ophir, both from our team, that will run the demo and show you how to crack a device. So I want to start with the IoT momentum in order to explain and frame our conversation of why organizations are paying so much money to have IoT security and IoT technologies. Gartner projects that new avenues of IoT-related services will generate $130 billion in new revenue. Organizations are jumping to take advantage, as Gartner predicts that by 2021, 94% of businesses will be using IoT. Add to that the data race. By 2025, there will be 80 billion connected things that will generate 180 zettabytes of data. That's a huge amount of data. Sorry. And it's not science fiction anymore. We see organizations that were early adopters that already implemented IoT gain revenue and increase revenue as a result. So I'm sure you all understand the amazing momentum around IoT, but let's discuss the security challenges that comes along with it. Let's start with legacy devices. These are devices that are very old. Some of them can be 10, 20, and 30 years old. It's really hard to secure them, and therefore they are becoming a real problem. Add to that the variety in IoT devices, where you see a lot of hardware, other industries, OSs, so there is no real standard around IoT. And multiply these two factors with the amount of IoT devices out there, and you will get a huge attack surface, probably the largest one in each IoT organization. And it doesn't end here. We see that all of these devices comes with insecure configurations, from default passwords, open ports, and processes that shouldn't be running if you want to be secured. All of these factors are becoming, and we see that the attacks are growing, and actually we see that Kaspersky Labs published a report showing the increased amount from 2016 to 2018, which actually demonstrate their IoT honeypots. So these are malware's attack, and you see the trend. And this is something that we see in every IoT security report. It's not something just Kaspersky predicts. Surprisingly enough, 35% of the organizations claimed that, or reported, that the attack that they suffered and the data breach that they had was related to IoT. So let's talk a little bit about famous IoT attack. Anybody heard about Mirai? Anybody? Oh yeah, we have one, too. Anybody in this side of the room? Okay. So Mirai attack was one of the most famous DDoS attack we ever seen, where hackers were able to compromise over 100,000 devices. And they were compromised and then weaponized to attack a service provider that resulted 24 hours of downtime in the internet. Think about the damage and the economic damage for these organizations. Another cool attack, well, I see it cool, is the fish tank attack. There was a casino in Las Vegas. They had a very cool aquarium and with very exotic fish. And they wanted to monitor the temperature of the water. So they used a thermometer to check it. The thermometer was needed, sorry. The thermometer needed access to the internet. So they connected that to their sensitive network. So that was the first mistake. A hacker was able to identify this thermometer device, find a vulnerability, and eventually he hacked their device. He started to lateral move from this thermometer directly to their database and actually download the database with all their traders. So I think that by now I've convinced you that IoT security is a challenging problem, and these figures explain how Microsoft is heavily invested in order to solve it. The sole purpose of this investment is to bring the best security products to the market. Azure Security Center for IoT enables you to unblock IoT innovation while keeping you safe and making sure all your IoT assets are secured. It is built on 4 main foundations. We provide you a single pane of glass where you can monitor from a Leaf device to IoT Edge and IoT Hub, but also we can connect your IoT-related services from the cloud, from storage, databases, virtual machines. Add to that the security posture. Once all those resources are in a single place, we allow you to run recommendations where we bring you all of the security posture and allow you to have a better security hygiene. So these recommendations, you will see them in the demo as well. Microsoft security product portfolio is deployed on billions of devices, and we use the intelligence we gather from these devices in order to bring you the most secure intelligence. And we are natively integrated to the cloud, and we are built for the cloud. So we are natively integrated with cloud services like databases, virtual machines, storages, etc. So when we built this product, we had you in mind, and we wanted to make it very flexible to your needs. We created 2 user interfaces. The first one is for the SecOps teams that he can consume the entire feed from ASC, from Azure Security Center. The second UI is for the OT and IoT personnel that can consume it directly from IoT Hub. Another thing that we've done was to create several detection engine in order to allow you to be very flexible. So the first thing is agent-based model. This is our open source offering, and you can deploy it directly on your devices. The second model is agentless, where we use IoT Hub telemetry, and we provide you anomaly detection. And of course, for Edge, we have a dedicated Edge security model for your Edge scenarios. And with that, we created adaptive security. So we have 3 layers of security, which start with recommendations. So this is where we want to improve your security hygiene. And we will provide you a lot of recommendation in order to make sure you reduce the attack surface to the minimum. The second layer is alerts. Once you have an attack, you want to know it really fast. So we have out-of-the-box IoT-related security alerts that will be triggered when you are compromised. Additionally, we are leveraging Microsoft Threat Intelligence. So once there is a new vulnerability, we will add Microsoft Threat Intelligence to make sure we have all of this in our feed. And lastly, custom alerts. So you have IoT applications, you know better what you want to secure, so we allow you to make sure you have custom alerts on these devices. So let's dig into IoT reference architecture. So each IoT architecture has 3 pillars. Things, these are the devices that we want to gather data from. Insights, these are the way we generate insights on the data we collected, and preferably create actions on those insights. So you can see in things that there are 2 optional architecture. So the first one is devices that directly connected to the to the IoT Hub, and the second one is devices that are connected to IoT Hub through IoT Edge. And you can see that the operating systems that we currently support are Windows Core, Ubuntu, Linux, and RTOS. The IoT Hub is our cloud gateway. That's what connects the IoT world to the cloud world. And we connect that to compute power and storage, so that will bring you the ability to generate insights. And eventually, you can connect everything to business logic, and in our case, even to SIEM solution. Once you take the IoT Hub and onboard it, and we will show you that in a minute, you will be able to secure the entire stack of your IoT assets and make sure you are not compromised. With that, I want to invite Ophir and Idan to show you a product overview and later on an attack.
Hey guys, so my name is Idan, I'm PM at the team, and I'm very excited to be here at Ignite. First thing I want to show you is how easy it is to onboard to our service, to Azure Security Center for IoT. And here we are inside the IoT Hub, I'm sure you're all familiar with. The only thing you need to do is go over the security blade and click on one of those pages. And you will be redirected to the onboarding page. And in only one click, all the IoT hubs of the subscription you entered will be onboarded to ASC for IoT. Now, let's go to an already populated environment in order to demonstrate how the solutions looks like. And we can see here the different resources that are linked to your IoT solution. And in a couple of seconds, I will show you how you can even add more resource groups in order to start monitoring them. But here you can see the recommendations and alerts that are relevant to the devices and the security posture of all those relevant resources. And alerts by dates according to their severity. If you want to drill down and see all the relevant alerts according to a specific time frame, you can go into the alert screen, and here you can see all the alerts that are relevant both, again, for your IoT devices and all other resources you linked to the ASC for IoT solution. Those alerts are based on both behavioral detection and threat intelligence, as Eti described earlier. Let's go to the resource page. Here you can see all the relevant resources in your IoT solution. And in 2 clicks away, you can add even more resource groups into this IoT solution in order for our solution to start monitoring it, give you relevant recommendation and alerts for suspicious activity. And the last thing I want to show you here is the custom alerts. The custom alerts lets you decide on specific security groups you can link devices into and create different thresholds that are specific to your IoT device's use case. As I guess you know, IoT devices are very straightforward. They do one thing and one thing only. They send specific data in a specific time frame. They run specific processes and communicate with specific IP ranges. And all those relevant data can be combined into a specific threshold. Any deviation from this threshold will trigger an alert that you can go on and investigate later. Now I want to show you how our solution integrates natively in the security ops workflow. And by onboarding to the IoT for the ASC for IoT solution, you will be added a new tile here in the ASC screen that is relevant for IoT Hub and other resources. And all of these resources and recommendations that we are generating will be reflected into the secure score of the ASC, and it will be very easy to understand and fix them. So with that, I will hand it over to Ophir, who will show you how an IoT-related attack looks like. Thank you.
Hi, everyone. I'm Ophir. Just a minute. I'm leading the detection team in Azure IoT Security. And today, I'm going to show you a real attack. We're going to do it live against a real IoT device. Actually, the device you can see over here. Before that, let's talk for a minute about IoT attacks. Eti talked about the Mirai botnet. We're talking a lot about the Mirai because we see it as a template. Mirai caused one of the largest DDoS attacks ever seen. It was actually caused by IoT devices, thousands of them. Anybody knows at what year we saw the Mirai, the big DDoS attack? In the audience, anyone? Okay, so the first time Mirai was seen was in 2016 with an attack on Krebs Security, which is a famous blog of a famous security author. About a month after that, Mirai source code was released. And a month after that, we had that huge DDoS attack. You can see here in the map the areas in the US on which the internet went down for a few days. This was actually due to the fact that the attack hit a DNS provider, and when the DNS was down, all those critical services were down as well. We are looking at Mirai as a template because its author actually released it as public source. He actually placed it on GitHub, which caused a lot of other attackers to take that code and use it. So in recent examples, like the one you see on the bottom, we see them using the same framework and just enhancing it. Golang, for example, which is the guy in the middle, is also looking for SSH keys all over the internet and trying to use them against devices. Satori is implementing some vulnerabilities in home routers and activating them as well. And they all use the same framework of scanning, and then when they find something, infecting, connecting to their botnet, to their command and control server, and then using all those devices for malicious attempts. And the fact is that when you have millions of devices connected out there, even if they manage to infect only 1%, it is still a whole lot of devices that are joined into their botnet, and they can do quite a lot of damage. So with that, let's look at some of the code that Mirai is using. This is a sample out of the default credentials that Mirai is coming with. Mirai used a dictionary attack of default credentials, and we will talk about that in a second. When it actually managed to infect a device, it kills all external communication in order to make it much harder to remediate the device. So once SSH port is closed, telnet, etc., I cannot log into the device. I need to physically connect into it, and it will be very, very hard to remediate. When Mirai is taking over an IoT device, it is also looking for other malwares and killing them. So much for honor between thieves. And last, when Mirai wanted to keep low profile, it actually had some networks that it didn't deal with. Okay, with that, I'm gonna start with our attack demo. And we're gonna actually, can you see the screen, the device? Can you see something about that device? Okay. So that device is actually a Raspberry Pi, you can see here, connected to a screen with a wireless connector. And the device is connected to Azure IoT Hub, the way usually IoT devices are connected. Everyone here uses IoT Hub, Azure IoT Hub? Anyone in the audience? Okay, great. So, let's look in the hub that this device is connected to. This is my hub. I have activated the security on this hub, the way Idan showed you earlier. And I have several devices connected. One of them is the device that you see here. Now, before I start, there are two ground rules that I need you to know, and it is very like a magic show. First one, what I'm doing here is called ethical hacking. I'm doing it for educational reasons to the device that we own in a controlled environment. You should not try to do that at home or at any professional network, and I'm serious about this. This is dangerous and illegal. Second one, the attack have several steps. So the same as in magic, I will appreciate some applause, some help from you each time we will be able to get to the next phase. Okay? Everyone ready? Understand the rules? Great. I see you guys are getting it. So here is the attacker screen. The first thing I'm going to do, our device is connected to a wireless network. So I'm going to have my computer join that network. So I'm going to init it. With the SSID of my network. Okay, now that I'm in the network, I will start scanning it. I'm doing a quick scan in the network, and I'm checking for port 22. Port 22, who knows what it is? SSH, correct. SSH, because usually those devices are using SSH. You need to somehow connect to them, manage them, and usually this is done with SSH. Once I have found something in SSH, there are several IPs here, but I'm drilling down into each one of them using Nmap, and what you can see over here is the exact version, kernel level, and also some information about the SSH key, which is modified. And to the best of my knowledge, it is very, very similar to IoT. So I'm going to put my money and bet this is the IP of the IoT device that we see here. And let's continue to the next phase and try to attack the device. We're going to take the password that you found over here, apply it to our script, and start attacking. Actually, what I'm doing now is very simple to what Mirai did. I'm doing default password or credential dictionary attack. Credentials are used in several ways. But what we're doing here now is looking for default credentials. Default credentials are credentials by which devices are manufactured with. Manufacturers, when they're shipping out appliances, they put in default passwords. There are no many options. There are very few options, a few hundreds of such devices. And Mirai did. Mirai, by the way, used around 60 default credentials. And with those only 60, it managed to infect thousands of devices. So I'm just using them each time I'm connecting. And as you can see, phase 1 is completed. We found our password. Guys, thank you. OK. So we found our password. We can also see some of the files around here that are real files of the device. That's the application that is running, Hello World application. And I'm going to move to the next phase. The next phase, I want to infect the device with my software. But I don't have an access to the device. I need to somehow to get software from my computer into the device that you saw over here. The way I'm doing it is something that attackers usually do. I'm asking the device to go ahead and fetch a file from the internet. This is a file that I've placed somewhere that only I know. It can be a legitimate web server that I control somehow. It could be my own web server. And I'm telling this guy, go ahead, fetch that file. It is actually a text file, which the device is downloading. And then we're changing it into a script. It's only a script file, and running it. Once I was able to run the script file, I actually infected the device, because now it's running my code on top of the regular code that the device is running. OK, so phase number 2 is completed. Yes, thank you. And now I'm moving to phase number 3, which is the command and control. Command and control server are servers that control such infected devices. And it actually, the benefit for me is that now I can remove my computer from the network. I can go home. This device now actually is pinging my server, the attacker server. It is pinging me and asking me, do you have a new command for me, boss? Now I'm the owner. He will do my commands. And what we did around here, we wrote a very simple command and control server with just asking the device to run a crypto miner. And you can see the crypto miner was loaded. You can see it here. We activated. It is running. And actually now, this guy is making money for me, the attacker. OK? So with this, we complete the attack. Applause. OK. And one more note, I really like your applause, but take up your application, give us some good feedback on the lecture. We will love it. Thank you very much. OK, so now that it is infected, let's go back to Azure Security Center. And let's see what kind of alerts we can see here. So we can definitely see that something went wrong. We have quite a few alerts. I will look into some of those. So we have a brute force attempt, which is exactly what we did, taking a user and trying different password. Worse, we can see that actually someone managed to log in to the device. We can see here the image of their crypto. This one is pretty interesting. Azure Security Center for IoT, each time a connection from the device is initiated to an external party, we check that connection, the external IP, with Microsoft Threat Intelligence feed. This feed is huge. Millions of suspicious IP that are coming from Azure and millions of other computers that Microsoft is monitoring and protecting. And we cross every IoT connection with that feed. Once we see something suspicious, the device opening a connection to an IP that is suspicious, we flag it immediately, and you will get the alert. Additional issues that you can see here, someone trying to hide his tracks, the fact that identity information was taken from the device, etc., etc. So we can say for sure that the attack was detected. You can see here the date. It is coming from now. This is something that you saw happening live. And with that information, what you can do, again, we're really, really hoping you will not have to do that, but in case someone was compromised, we showed them the full picture of where did the attack come from, what happened on the device itself, what are the external IPs, and as you can drill in here into the details, you can get more and more information. And as Eti mentioned before, you can take those alerts, send them to your SIEM or any other security management system that you have in your organization. What's more interesting is the recommendation that we mentioned earlier. This is very important because this entire attack could have been prevented if those recommendations would have been fixed. So actually, we have here 3 recommendations. First one is about the fact that the device has open ports. And it is true. We did use port 22 in order to connect to the device. But sometimes you do need that port open. So the second one is talking about the fact that the firewall policy is too permissive. Sorry, that's the third one, this one here. The firewall policy is too permissive. So if you do need SSH open, you must restrict it only to specific IPs coming from your organization or the one that you usually use. Otherwise, if it's open too wide, people can do the same attack that you just saw and break the device. And the second one here in the middle is talking about the fact that the OS is not up to date. If the OS would have been patched, infecting the device would have been much more difficult. So we give you both pillars, alerts when applicable, and recommendation how to avoid those attacks in the first place. So with that, we're going to continue with Eti. Thank you.
Thank you for Dan for this demo. So as Ophir mentioned, one of the most popular attacks and infection vector against IoT are still cracking telnet and SSH ports and passwords. You've seen in the demo you can use one of 3 modules. So it's alerts, recommendations, and custom alerts. This is just an example of area where you can use our recommendation to take proactive approach and reduce the attack surface. And you can even make it smarter. You can add to the baseline known geolocations that you should block in advance, and you get to reduce to the minimum the attack surface as well. These are the top 10 attacks in 2018. You can see there are some flavors of Mirai and some other malwares. So when something bad is gaining control over your IoT assets, you can monitor it through our alerts, and we provided it in aggregated data, and you can drill down to the raw data and investigate it. We're currently working with the leading companies in the IoT field in order to secure their assets. We launch a new monthly calls where we invite all of you guys to join, where we keep you updated about vulnerabilities, new features, and even access to private preview features. So just send an email and we will join you. We've GA 3 months ago, and while we aim for cool new features to be announced in our RSA, we pushed ourselves to make sure that governments will be more secure. So with that, we are announcing the support of US Gov and China Gov regions in December this year. And then I just want to give you a taste of RSA 2020. We are working on integration with Azure Sentinel, where you will be able to have an investigation story and work from Azure Sentinel on your IoT attack scenarios. So you've seen how easy it is to attack a device, but you've seen also how easy it is to use our security models to secure it. So if there is only one takeaway from this session, is when you come back home, put the security on. So stay safe, and thank you very much for your time.